Hello guys, welcome to the grade 11 mathematical Euclidean geometry lesson where we will be having a look on settled Euclidean geometry, or you can say riders. What are the riders? Riders are the problems consisting of settled Euclidean geometry like this one. So before we can dive into riders or the problem consisting of settled Euclidean geometry, let's just remind ourselves of circle and parts of the circle. So we have got a circle here and some parts of the circle with their definitions here on this side. So we have got the circumference on the circle, we have got the diameter, we have got the radius, we have got the chord, we have got the segment, the sector, the secant, and the tangent. These are the terms that we are going to use throughout grade 11 settled Euclidean geometry. So you guys, it's a must for you to know the definitions of these parts of the circle because hey, you are going to need them. Hey, what is a radius? Just a little reminder on what is the radius, what is the diameter, what is the chord. What is the radius? A radius is the line from the center to any point on the circumference of the circle. So if this is the center, then that is the radius. This is the radius. That is the radius. So the radius is equal everywhere. So this part to that part is equal to this part from here to that one. And also both of those lines are equal to this part of the line here. Okay, that is the radius. And then what is the diameter? The diameter is a line passing through the center of the circle, and it is the double length of the radius. It moves from the point on the circumference to the other point on the circumference, but it passes through the center of the circle. That is the diameter. Okay, now we go to the chord. What is the chord? The chord is a line with endpoints on the circumference. So the endpoints of that line are on the circumference, and the chord doesn't pass through the center of the circle. Okay, that is the chord. Now, let's go for the tangent. What is the tangent? The tangent is the line touching the circle at one point there on the circumference. So this is the tangent, and it touches the circle at one point. That is the tangent. We are also going to use a tangent a lot in grade 11 Euclidean geometry. Okay, now what is a secant? A secant is a line passing through 2 points of the circle. It doesn't end there. It doesn't only end here. It goes outside of the circle there. That is a secant. And then we have got the sector, which is this part between the radius or radii, because plural of the radius is radii. So let's say we have a radius here, radius. This is one radius, but once we are talking about 2 of them, 3 of them, now we will talk about radii. That is the plural of the word radius. Okay, now let's move on to the other part. We are done with the reminder of the circle and the parts of the circle. Okay. Oh, now I love this part. I love this grade 11 Euclidean geometry. Now let's dive into today's business. Okay. Theorem 1H. The perpendicular line drawn from the center of the circle. You know what is the center of the circle, right? To the chord. Bisect that chord. So this is the keyword. This is the mathematical keyword that you know, guys, from grade 8. What is being meant by something, by some lines that are perpendicular. So if I'm saying my blue line here is perpendicular to my orange line here. What I mean by that? I mean there, at the intersection there is a right angle there. What is a right angle? A right angle is an angle that is exactly equal to 90 degrees. That is a right angle. And then we have got acute angle, which is the angle that is less than 90 degrees but greater than 0 degrees. That is acute angle. We also have obtuse angle, which is the angle greater than 90 degrees but less than 180 degrees. That is obtuse angle. We also have got a straight line, which is that equal to 180 degrees straight line. We also have a reflex angle, which is the angle that is greater than 180 degrees, but less than 360 degrees. And then now, the angle that is exactly equal to 360 degrees is called a revolution or angle around the point. So, okay, I was just reminding you of these types of angles from grade 7. Okay, now we go back to that perpendicular. We means that at the intersection of them, it's a right angle. It's a 90 degrees angle. So this line that is drawn from the center of the circle to that chord is perpendicular to the chord there, and it bisects this chord. Now, this is also a mathematical keyword. What does bisect mean? Bisect. Before we can go to the word bisect, let's first understand a word intersect, right? Before we go to the word bisect, let's come to the word intersect. What does intersect mean? Intersect means cut each other, meet each other, crossing each other. That is intersect. If maybe my orange line and my blue line are meeting there at A, I will say the blue line and orange line are intersecting at the point A. That is intersecting, just intersection. So OM here and AB are intersecting at M here at this point. So I believe now intersect makes sense to you. So if you understand what does the word intersect mean, you will definitely understand what does the term bisect mean. Now, bisect, bi means two, right? Bi means two. Bisect, now it means that you cut something into two equal parts. Now this line that is drawn from the center that is perpendicular to the chord bisect the chord, meaning this line cuts this chord into two equal parts. Therefore, now MB is equal to AM because OM bisects AB. I hope that makes sense. This is theorem 1 in a nutshell. So they are saying here, theorem 1 in a nutshell, according to the given circle here, or let me remove my mess here so that we can have a look on this circle. Now, according to the given circle sketched below, if OM is perpendicular to AB, this is the sign for perpendicular, which means M1 is 90 degrees and M2 is equal to 90 degrees. Those angles are right angles, okay? Then AM is equal to BM. That's what I said, because OM bisects AB. What does bisect mean? Bisect means you cut something into two equal parts. I hope that makes sense. So if we say OM bisects AB, we mean OM cuts AB into two equal parts. Therefore, AM will be equal to MB. I hope that makes sense. Okay. Now, if you are given a circle with the center O, such that OM, which is this one, is perpendicular to AB, and that AB is a chord, then you are required to prove that indeed AM is equal to MB, guys. Please listen this carefully, because you might be assessed this proof in your paper there. You must know the proofs, guys, not only application that you will be required to know. Only also the proofs you will be assessed on them. So now you only will be given this part in exam. There won't be this line here. This part here. It won't be there. This one. Okay, even if I didn't remove the whole thing, but you can see. So now, the first thing that you will do, because here you are just given that there's a line OM that is perpendicular to AB. You just have to prove that this line AM is equal to the line MB. The first thing that you will do is to join AO or OA. You construct something there, which is this one. Okay, you constructed it there. And again, you join OB or BA that side, like this. Okay, that's the first thing that you will do. Now you will have the two triangles OMA, and OBM, which is this one. Now you are going to prove the congruency between the two triangles. What do we mean by triangles are congruent? We mean those triangles are exactly the same. Those triangles are exactly the same with length, the size, the corresponding angles are the same. So the first thing that we know, OA is the radius, OB is the radius. Therefore, we said the radius is equal to, it can be a radius that is here. If the radius is 2 centimeters, also this radius will be 2 centimeters. Also, this one will be 2 centimeters. Also, OB will be 2 centimeters. Also, OA will be 2 centimeters. So the radii of the circles are always the same. So OA here is equal to OB. The reason being radii. So now, guys, this part in Euclidean geometry, this is the statement, this is the reason. So please, guys, always in Euclidean geometry, put the statement and put the reason. Put the statement and put the reason. Don't only put the statement, say OA is equal to OB and leave it like that. Oh no, you're not going to get the full marks by only doing that. So you have to provide the statement, accompany the statement with a reason. A statement, a reason. So a backbone of Euclidean geometry is the reasoning, because without the reasoning, you won't get the full marks. So why do you say OA is equal to OB? Because OA and OB are radii of the circle. Yes, that is the valid mathematical reasoning. Now, let's go to something that we can do. We have M1 here is equal to M2. They are both equal to 90 degrees. Why do we say that? Because we are given that OM is perpendicular to AB. There, we are given that. That is the reason. Because we are given that. The thing that we don't want here is to assume if you are not given or you can't prove that using a mathematical reasoning. You can't assume here. You have to state a reasoning or say something that you were given. Okay. The third one now, OM in this triangle is equal to OM in this triangle. That is the common side in this triangle and this triangle. Therefore, this triangle is congruent to this triangle. Therefore, this is the sign to prove congruency. These horizontal three lines are for congruency. So I don't want you guys to confuse the congruency and similarity. These horizontal three are these are sorry. Now these ones I want these I want okay. I want some this, okay. Within okay eraser I removed. Okay, I'm sorry guys for that. Now, these vertical ones are for similarity, and then this horizontal one are for congruency. I hope that makes sense to you guys. So now we have proved that triangle OAM is congruent to triangle OBM. Then the reason is the right hypotenuse side. We use that. That is the condition, one of the conditions to prove the congruency between the triangle you guys have learned in grade 10. Okay, thank you. Then by us proving the congruency between the two triangles, because already this side is equal to that and this is equal to that, automatically AM will be equal to MB. Then now we are done with what? With theorem 1. We are done. Now we are going to proceed to the converse of theorem 1. So converse, we are doing what we have learned in theorem. Now we are doing it in reverse, right? Because up there we were given that um, that some lines are perpendicular, which is the line drawn from the center to the chord. Those lines are perpendicular, and we were given that that was all. Oh, we were given that the line from the center bisect the chord. We had to prove that AM is equal to MB. Now, what if we are given that AM is equal to MB? Then we will have to prove that this angle is 90 degrees. This angle M2 and M1. We have to prove that OM is perpendicular to AB. That is the converse of theorem 1. The line segment joining the center of the circle to the midpoint of the chord is perpendicular to the chord. The line segment joining the center, which is the center, and the midpoint of the chord. What is the midpoint? It's the half of that line. At the midway, if I travel from that part and I traveled for 5 kilometers from A to this part, also from this part to that, it will be 5 kilometers. Therefore, this is the midpoint. So if there is a line from the center of the circle to the midpoint of the chord, that is if AM is equal to MB, then OM must be perpendicular to AB. That means M1 must be equal to M2. They both must be equal to 90 degrees. What can you given in the converse? You will be given the circle with the center O, then M is a midpoint on this chord. Then you are required to prove that OM is perpendicular to AB, right? That is, you are required to prove that M1 is equal to M2. They are both equal to 90 degrees. Okay, now let's jump into this proof. Like I said in theorem 1, you won't be given this construction here, these ones, but you guys can see what I'm doing here. You won't be given these dots here. These dots will be drawn by you. You will join OA and you will join OB. That is your duty. That is the first thing that you will have to do. You will join OA and join OB. Okay. Now you will have two triangles by joining OA and OB. What are those two triangles? Is OMA and OMB, right? Okay. Now, in the triangle OMA and the triangle OBM, which is this one, we have to prove the congruency between the two triangles. What do we know about these triangles? They are in the circle. OA is equal to OB. That is the statement. What is the reason behind that statement? Why do I say OA is equal to OB? It is because they are radius, right? What is radius? A radius is the plural of the radiuses. I can't say a radius because now there are two radiuses. So now in mathematical language, these are radius. Radius. That is my number one. Number two, AM, we are given that AM is equal to MB. What is the reason behind that? We are given that from the statement here that AM is equal to MB, right? Yes. Now, OM is equal to OM from this triangle and from that triangle. Therefore, triangle OAM is congruent to triangle OBM. Why? We used side, because we used the three sides to prove the congruency between these two triangles. Therefore, now the corresponding angles will be equal to each other. So now what are they saying here? They are saying, but AMB is a straight line. This is the straight line. So what is the sum of angles on a straight line? Is 180 degrees. And we want these two angles to be equal from that one, so that when we add them, they give us 180 degrees. Then automatically angle M1 and angle M2 will be equal to 90 degrees. Reason being adjacent angles on the straight line. What does the term supplementary mean? Now, in terms of angles, we will have a term supplementary and complementary. Supplementary, we mean now here sum up to 180 degrees, complementary summed up to 90 degrees, right? This one supplementary is just that S. So now this will be 180 degrees. Then complementary, that C, you can transform it into 90. Then this one sums up to 90 degrees. I hope that makes sense. Thank you, guys. Let's move to the next part. We are having the definition here that they're saying. The perpendicular bisector. What is the bisector? It's something that cuts something into two equal parts. So the perpendicular bisector of a line is a line that bisects the given line at the right angles. In the diagram, OM is perpendicular to a bisector AB. Oh, okay. This is AB, and ON is perpendicular bisector of CD. Bisector of CD. So ON bisect CD and OM bisect AB. Fine. Theorem 1B. Okay. Is this the last one? Yes. From here, we'll be going to theorem 2. Okay, nice. Are we moving so fast? I don't hope so. Maybe I'm accommodating everyone in this lesson. Okay. What does theorem 1B say? A perpendicular bisector of a chord. This is the perpendicular bisector to this chord. Passes through the center of the circle, right? Okay. Given now that the chord AMB with the center, yeah, now, okay, the chord of the second O with the center O. Okay, let's go. CM is the perpendicular bisector of the chord AMB. Now, we are required to prove that O lies on CM. You see? Here, you might be scared. Now, let's assume that the center of O doesn't lie on the perpendicular bisector CM. Now, let's shift that O to any direction. You can shift it here. You can shift it somewhere here. It's up to you. Okay. Now, M1, we know that M1 there is 90 degrees. We are given that. Why? Because this is a perpendicular bisector. So we know in grade 11 what does the term perpendicular mean, right? We are given that. But M3 is equal to 90 degrees. The line from the center to the midpoint of the chord A and B. from that theorem and the previous. So now M1 plus M3 is equal to 180 degrees, which is now impossible to add another angle there, there, which is this M2, M1 plus if we already have this as 90 and this as 90, there's nothing that we can add so that we have angles on the straight line as 180 degrees. Now it forces this angle M2 to be 0 degrees. Therefore, O lies on CM, right? Okay, now let's have a look on this example here. Here, they are saying O is the center of the circle. So guys, please, when you are approaching the riders, don't just come to this and now say, what am I required to find? AB, and you come here to find AB. No, that's wrong. Read everything that you are given just to ensure that you note what you are given that you can use to calculate whatever you are required to find. It will be simple that way. O is the center of the circle. We are given AC as 8. This is AC, right? Okay, and OB is 3, and OB is perpendicular to AC. Now, according to theorem 1, BC is equal to AB. Therefore, this and this are equal. Then BC will be 4 and AB will be 4. From that 8, we divide that 8 by 2. Okay, and then now let's just do some analysis. This here is 3, this here is 3. Using Pythagoras theorem, what OBC can be? OBC will definitely be 5. How 5? Look, okay, let me just explain this solutions, because what I'm going to say is exactly what is written here. So AB, they are saying you have to find AB. AB, we found it here. Why? Because this is just the statement. AB is equal to BC is equal to 4. Accompany that statement by a reason. So that is a perpendicular line from the center to the chord. That is the reason. Now B, OC. That is OC. Now you will use Pythagoras theorem. I don't know why they didn't provide the reason here. I was going to mark them wrong. You have to provide the reason. This is a Pythagoras theorem, and Pythagoras theorem is applicable on a right-angled triangle. What is a right-angled triangle? Is a triangle with one angle as a right angle. You know what a right angle is. Okay, now we know that BC is 4. This is 4, and we know that OB is 3. Using Pythagoras theorem, hypotenuse, guys, is the longest side in the right angled triangle. So hypotenuse squared plus the sum of the square of the other side. So 3 squared plus 4 squared is equal to 9 plus 16, which is going to be 25. Now, remember, I want OC, not OC squared. Now, to remove that squared, I will plug the square root. Now, since this is the equation, whatever I do on the left-hand side, I should also do on the right-hand side. Therefore, I put the square root here. I also put the square root here. Now, OC is equal to 5 units this side. So, OC is equal to 5 units. Okay, just like that. Now, let's go to example 2 here. On the center, O is the center of this circle, and then AC is equal to 16. Okay, AC is 16. AB is equal to BC. Now, since we are given that AB is equal to this, we can divide this 16 by 2 such that this will be 8 and this will be 8. And OA is 17 units. Calculate the length of OB here. Okay, now, why will we say AB is equal to 8? Because we're given a line from the center to the midpoint of the chord, meaning now this is the midpoint of this line. This divides the line into 2 equal parts. Okay, now let's use Pythagoras theorem to find OB. We have this, we have this. So now we will say OB is equal to the hypotenuse minus the existing side, and then you square the two sides. Now you will have OB squared is equal to 5. We want OB, we will plug the square root on the both sides. Therefore, OB is equal to 15 units. Okay, now this is the exercise. Will be counted as your test, guys. Now let's move to the next theorem. What is happening? Okay. Okay. Why? Okay. I now don't know what happened here. Yes. Why do this pen of mine doesn't run right? Levels of this thing does me dirty. Okay, we are here. Subtended angles. Arc APB. Arc APB. This is the arc. So that arc APB or the chord AB subtends angle C at the circumference. So this arc or this chord subtends that angle. Hey, I want my pen back so that I can be able to write. Okay, now it is back. Okay, so that arc subtends this angle and this chord subtends this angle. Okay, now let's come here. Arc APB or the chord AB subtends angle AOB, which is this one at the center of the circle. Okay, now let's go to the next theorem, which is theorem 2. The angle which an arc, this is the arc, right? Okay, subtend at the center of the circle is twice the angle it subtends at the circumference. I don't know if this makes sense. Eh? Does it? Let's go back to that part. The arc or the chord, this is the arc or the chord, subtends that angle at the circumference. Okay, fine. Arc APB or the chord AB subtends this angle at the center. Now, let's come here. The angle which an arc of the circle subtends at the center of the circle is twice the angle it subtends at the circumference. Hey, this is English. Eh? What does that mean? Angle at the center is 2 times angle at the circumference, right? Angle at the center will be 2 times angle at the circumference. That's what this theorem simply says, right? If you're having something like this, just know that angle at the center is 2 times angle at the circumference. If this x is x, if this angle is x, this angle will be 2x. Now, same applies. We have that angle at the center. We have that angle at the circumference. Angle at the center is 2 times angle at the circumference. Same applies with this one. Angle at the center is 2 times angle at the circumference. Okay, I hope this makes sense to you guys. Now, let's move to what we are given so that we can just prove. And then after proving, we do some example. After examples, we will go to the next theorems. Hey, this geometry is nice, guys. Believe me, there is no geometry that you will enjoy than this one. Hey, I just hope and wish it will make sense to everyone, because most of students get to be bored by this lot of theorem. So now, given a circle with a center O, we can see that all these circles have got the center O. So given this circle with a center O, and what is this? ABC are points on the circumference, okay, of the circle. Now, you are required to prove that this angle AOB, A OB is equal to 2 times angle ACB there. Okay. Now, what is the first thing to do there? Okay. In paper, you will just be given something like this because you guys have to know these proofs. You have, right? You have to know these proofs. Okay, okay. You won't be given this line here. Yeah. Then what you will do is to just join CO, which is this part, and then produce that CO2 here. Right? Fine. Now we will have C1 and C2, O1 and O2. Yes. Now O1, which is this part. O1, I don't want the white one. O1 is this one, will be equal to angle A, which is this one, plus C1, using that property of triangles. If this is triangle, then this exterior angle will be equal to the sum of interior opposite angles. So this angle here plus that angle there is equal to this angle that is outside. So what is the reason behind this statement is exterior angle of a triangle OAC. OAC. Thank you. Now, but C1 is equal to A. C1 is equal to A. Why? OA is equal to OC. So triangle OAC is an isosceles triangle since this line is equal to that line. So the reason behind that, you can just say because OA is equal to OC, they are radii. Then you can just say O1 is equal to 2 times C1. Similarly, on this triangle, you will say C2 is equal to, O2 is equal to C2 plus B, and C2 is equal to B. Why? Because OC is equal to B is equal to OB. And then now, why is OC equal to OB? Because they are radii. Therefore, you can say now O2 is equal to 2 times C2. Now, we come to this part. Now, we have O1 here and O2 here. You take O1 plus O2 is equal to, what was O1? O1 was given by 2 times 1 plus, what was O2? O2 was given as 2 times C2. You write it there. Now, you just take 2 as a factor here. Now, okay, O1 plus O2 is equal to 2 times C1 plus C2. O1 plus O2, there we can see that it's just angle AOB. Angle AOB is equal to 2 times C1 plus C2. There is ACB. Is ACB. We can see that, guys. By that, we are done proving that angle at the center is 2 times angle at the circumference. Right. Now, let's move into the upcoming example. Yeah, we are having these examples here. O is the center of each circle. Calculate the value of the unknown letters X, Y, and Z. Okay, this is the angle at the center. That is angle at the circumference. Now, this angle is 2 times that one at the circumference. Therefore, 130, not 80. Hey, what is happening? Hey, I don't know what is happening with this. I'm sorry for that, guys. I don't know now what is happening with my PC, but okay. We were saying the angle at the center, which is 130, is equal to 2 times angle at the circumference. What is angle at the circumference? It is x. Now we want the value of x in this equation. Now we do what we have learned from grade 7 equations. We divide by 2 on both sides. Therefore, now the value of x is equal to, is it, I don't know, 130 divided by 2 is 65. degrees. So guys, please, in Euclidean geometry, we are not talking about just numbers. We are talking about angles. So do write that angles. This is 65 degrees, just like that. Okay, thank you. Now, we come to this one. Angle at the center is 2 times angle at the circumference. What is angle at the center? It is 50. That 50 is equal to 2 times angle at the circumference. What is angle at the circumference? Is y. Now we want the value of that y. We will divide by 2 on both sides. Y will be equal to 25 degrees, not just 25. Okay. Now we move to the next one. Now we have angle at the center and angle at the circumference. What is angle at the center? Now I'm asking you guys this one. What do you think that will be equal to? Okay, we will say now this one, angle at the center is equal to 2 times angle at the circumference. We divide by 2. Now z is equal to, what is 270 divided by 2? It gives me 135 degrees. You are just done. But guys, for these, if this was 2 marks, 2 marks, 2 marks, you will get 1 mark, 1 mark, 1 mark, meaning you will get 3 out of 6. Do you know why? Because these are only statements with no reasons. So I won't give you a full marks. You will have to include the reasons. Why is this equal to 2 times that? Because angle at the center is 2 times angle at the circumference. So also for this one, you will include that there is an angle at the center is 2 times angle at the circumference. Angle at the center is 2 times angle at the circumference. Thank you, guys. Let's now move to the next example. Example 4 here. Okay. O is the center of each circle. Calculate the value of these unknowns x, y, and the z. Now, angle at the center is 2 times angle at the circumference. What is angle at the center here? Angle at the center is x is equal to 2 times angle at the circumference. What is angle at the circumference? It is 62 degrees. Now, that x is equal to 2 times 62. It gives me 124. What is the reason behind that? Angle at the center. Oh, this is the reason. There's no need for me to write this. I'm sorry. There's no need for me to write this reason. You can just take that reason. You will have to write the reason in your answer sheet. I don't have to write the reason, but I tell you guys, you have to write that reason. Angle at the center is 2 times angle at the circumference. That is the reason. We come for this one. Angle at the center, which is y is equal to 2 times angle at the circumference is equal to 2 times 23. Therefore, it will be equal to 46 degrees, guys. Degrees. Y angle at the center is 2 times angle at the circumference. Same applies with this example 4, guys. Now, we are done with theorem 2. Now let's move to the next theorem. Okay, I move, which is theorem 3. I love this theorem, guys. So please pay attention in this theorem, guys. Pay attention. Hey, it doesn't have example. Okay, now in theorem 3, they say the angle subtended at the circle by the diameter is a right angle. We say that the angle in a semicircle is a 90 degrees. Reason being, angle in a semicircle. Okay, now theorem 3. According to the given circle sketched below, if AB is the diameter. And there are some lines that are drawn there, AB and AC. They meet there at C. That angle C there, guys, will definitely be 90 degrees as long as this is the diameter and there are lines there from that diameter to that angle C. Angle at that C will be a right angle. Okay. Reason being angle in a semicircle, right? Okay. Now, if you are given that AOB is the diameter, we want to prove that this here is a 90 degrees there. Now, AOB here is angle at the center. This is angle at the center. That is angle at the circumference. And we know that this angle here is equal to 180 degrees. What is the reason behind that? It is the straight line. Now, we want that angle. If this is angle at the center and is 180 degrees, we want angle at the circumference. So this angle that is at the center is equal to 2 times angle at the circumference. It will be 2 times y. Now, what is the value of that y there? Y will be equal to 90 degrees. Therefore, we have proved that the angle C there will be 90 degrees, just like that. Now, let's go for the converse of this theorem, right? Now, we said the converse is the reverse. So now we will be given that that angle is 90 degrees. So if you are given that this is 90 degrees, automatically AB will be the diameter, right? So the converse of the theorem is the reverse of the original theorem. The converse of the theorem 3, if the angle subtended by the chord at the point on the circle is 90 degrees, if you are given that this is 90 degrees, then that chord is a diameter. This is the converse. According to the given circle sketched below, if C is 90 degrees, then AB is the diameter. You have to know this, guys. Now, calculate in example 5. Oh, I'm sorry to move this fast, guys. Okay. In example 5, calculate the value of the unknown variables. O is the center in each case. This is A, we want X. Now, we are given that O is the center and OAB will definitely be the diameter of the circle because we now know what is the definition of the diameter. We want the value of X. If this is the diameter, by theorem 3, we know that this is 90 degrees. We want that. Now, X plus 60 plus 90 is equal to 180 degrees, reason being the sum of angles in the triangle. Why did we say this is 90? By theorem 3, that is angle in a semicircle. Okay, now X will be 180 degrees minus 90 minus 60, and X will be equal to 30 degrees. Okay, B, you want the value of X there. Okay, we know that the angle R, everything is 90 there. Why? That is angle in a semicircle. Then that 90 minus 42 will give me 48. Then X is equal to 48. Okay. Now, exercise 3 will be given to you guys as a test. Now, guys, thank you for being in this lesson. I will meet you guys in the next one. I hope you guys enjoyed, and I hope you will also enjoy the next lesson. Thank you, guys. Thank you, guys. I'm now logging out of this lesson. Bye.